All right, we are going to move on to talk about Arrhenius acids and bases, and you'll see how kind of our definition and understanding of acids and bases is going to grow from here. So an Arrhenius acid is a substance whose water solution contains the hydrogen ion, which is H+, as the only positive ion in an aqueous solution. This is actually the definition that you're going to normally see. So this is the only positive ion when it's been reacted with water. So just be careful, realize that not all substances containing hydrogens are acids. You always want to be checking on table K. If you look on table K, you'll see we have this list of common acids. All of these can work as an Arrhenius acid. You'll see a lot of the times they will put, let me just pull up my highlighter, you'll see like the hydrogen out in front. For a lot of them, that shows the one that's going to actually undergo this ionization, or something like sulfuric acid, which has 2. Just be on the lookout for where you see this very last one, which is acetic acid, where it has this COOH group. That signifies that you actually have a acid, and it has to do with this hydrogen that's written at the end. That's the one that gets ionized. So just be on the lookout. That's like a special little one that you could see. Or sometimes you'll see it with, again, that hydrogen out in front. So always be checking table K for Arrhenius acids. So the hydrogen ion, the hydrogen normally by itself has 1 proton and 1 electron. So if it's an H+, that means it lost an electron. So it's just simply a proton. And a proton isn't going to just exist alone in water. It's attracted to the unshared pairs of electrons on water. So if you remember, we've talked about this a couple times so far this year. We have water, and oxygen has those unpaired electrons. Well, that hydrogen ion, so think of this as these guys are negative. Okay, if I have this hydrogen ion, we know opposites attract, so it's going to get attracted and bond with the water to produce H3O+. Okay, when that proton bonds with the water, it forms the hydronium ion. Okay, and this is really important because sometimes you will see them talk about Arrhenius acids with the hydrogen ion, and then a lot of the times you'll see with hydronium. So the properties of acids are really the result of this hydrogen or hydronium ion. One little thing in terms of some students kind of mix up hydronium or can't remember what it is, they do actually have it on table E, okay, right up at the top here. So you can always look that up if you need it. All right, so when hydrochloric acid, or HCl, dissolves in water, its acidic properties are a result of that hydrogen ion produced. So this actually normally has a covalent bond here. That's going to break or ionize, and you get the hydrogen ion in solution and the chloride ion. And again, that hydrogen ion is then going to react with water to produce that hydronium ion. Okay, Arrhenius bases is a little bit different. This is a substance whose water solution contains the hydroxide ion, OH-. Okay, and again, that hydroxide ion is also on table E, so you don't mix them up, which is pretty common, especially when you're doing an assessment. So hydroxide's right here. Now, the thing you have to be careful for is this is a hydroxide ion, so it's going to be when you have a metal attached to it. So you will have your metal ion plus your hydroxide ion. Okay, or there are some exceptions. You could have something like the ammonium ion or something that makes it an ionic compound. So you want an ionic compound. And the reason why I bring that up is that not all compounds that have OH in the formula is a Arrhenius base. So the most common example that they will try and throw at you is when they have OH with a carbon, and usually that carbon is out in front. So that's actually just a organic alcohol, and it is not a base. So just be careful if you see carbon out in front and then you see that OH there, it's not actually a base. They're going to have that hydroxide usually bound into a metal or another polyatomic ion. And then according to the Arrhenius theory, the properties of acids and bases are explained as properties of that hydroxide ion. And then here you want to be thinking about table, I'm going to say L, just check, SL. So check table L. Now the thing with table L is you're going to have these first 3. Okay, with the sodium ion, potassium ion, calcium ion, those guys are all your Arrhenius bases. It doesn't have to just be those three. You could have any group 1, group 2 ion with hydroxide. You could also have other metals. Aqueous ammonia, NH3, that doesn't fit with our Arrhenius bases, even though it shows properties of a base. So that's where we'll come back to at the end of the unit to kind of see where we had to go in order to include that. So going back to our Arrhenius bases though, when sodium hydroxide dissolves in water, its basic properties are due to the hydroxide ions produced. So you're going to have the sodium ion dissociate from the hydroxide ion so that you have your sodium ion plus that hydroxide ion. Okay. And that's what gives it its basic properties. Okay, so right now you're just going to be kind of going through in the practice of just categorizing or classifying Arrhenius acids and bases. And then we'll kind of go from there after we go into the pH scale. We'll come back to Arrhenius acids and bases when we get to neutralization and why that hydrogen ion and hydroxide ion are going to be really important.